My name is Galen Weld, and I'm very excited to present to you today our evaluation framework for causal inference with text data. Text data from social media platforms offers the exciting potential to let us answer causal questions. Questions where we want to quantify the impact of some intervention, like therapy, on some outcome, like self-harm. And frequently, a goal is to estimate the average treatment effect, or ATE. Oftentimes, we want to do this in an observational study, one where we don't have control over the intervention. And the challenge with observational studies is that there are often confounding factors that we need to adjust for. For example, people who struggle with depression may be both more likely to receive therapy as well as more likely to self-harm. And recently, a number of different methods have been proposed which use observed covariates represented in text data, like you might find on social media platforms, to adjust for these confounding factors. But the big problem is that these methods are extremely difficult to evaluate because there's almost never any ground truth. We just don't know the right answer. And as a result, it's difficult to know which method is best for each application. Now, this wouldn't be such a big problem if all of the methods agreed with one another. However, we show that unfortunately this is not the case. Using two different real-world tasks, we show that many different commonly used causal inference methods disagree with each other on their estimates of the ATE. Again, in these experiments, we don't know the ground truth, so we don't know which method is correct, but if they disagree, they can't all be right. Clearly, we need a better way to evaluate causal inference methods. Our contribution is a semi-synthetic evaluation framework which consists of 5 different tasks. And each task is created by inserting synthetic posts into real Reddit user histories according to a known probability distribution which lets us know the ground truth ATE. Let me give you a quick example of how this works with one of our tasks, the signal intensity task. We start with a bunch of real Reddit users represented by their post and comment histories. And we imagine a simplified universe where there are only 2 types of people, class 1 and class 2. And we randomly assign the Redditors to each class. Now, these classes are hidden from the method. The job for those methods are to try and identify which class each user belongs to using synthetic posts that we've inserted into their histories. For the signal intensity task, we simulate a situation where methods need to distinguish between users based on the number of posts that they make. And so to do this, we append a single synthetic post to class 1 users' histories, while we append 10 synthetic posts to users from class 2. Thus, the method is required to count the number of synthetic posts that each user has in order to differentiate between users of each class. And if the method can do this accurately, it will end up with an unbiased estimate of the true ATE. So why do we use semi-synthetic evaluation for our framework? 2 reasons. First, it combines the best of both worlds. We get the realism of real-world data with the known ground truth of synthetic tasks. And second, semi-synthetic evaluation is widely used in other domains. Here, we contribute the first evaluation framework specifically for use with text data like you'd find on social media platforms. And we make our framework public, along with the code to use it, so that we can all evaluate and improve our causal inference methods. Using our 5 tasks, we evaluate every commonly used causal inference method for text data, conducting over 600 experiments. And I'll just summarize some of our key takeaways here. We find that more complex, transformer-based models generally perform the best. However, more complex models are not universally stronger. They struggle with counting and with limited amounts of training data. We find that high accuracy on propensity scores isn't necessarily a good thing. Often it reflects strong selection effects, not low ATE bias. In general, the choice of text representation and propensity score model has a far greater impact than the choice of ATE estimator. Concerningly, we find that many methods fail a placebo test. They predict a causal connection when one isn't present. But there's lots of room for optimism here. Our new Sherbert model leverages recent NLP developments and performs the best of all of the methods that we evaluated on most of our tasks. And we make this model public. Now, if there's one thing that I'd like you to take away from this work, it's that principled evaluation of causal inference methods is really important. We need to be careful about how we develop, evaluate, and select the methods that we use. To this end, our framework is easily extensible, so you can add new tasks specific to the challenges in your area of research. And last, we make our framework and code public so that everyone can use it, including both researchers developing new methods as well as those applying them. Thank you so much. Please take a look at our paper and our website to learn more.